Hi everyone, welcome to another episode on my WAEC math series. So in this episode, we'll be discussing standard form. The number is in its standard form if it is written in the form a times 10 raised to the power n. The number is said to be in standard form if it is written in the form a times 10 raised to the power n. Here a is a number between 1 and 10, and n is an integer. What do you mean by that? The number a here have to be between 1 and 10. That is, it is greater than 1, it is less than 10. It might be 1 also. Starting from 1, 1, 1.1, 1.2, above. Then up to what? Up till 10. And then that power n must be an integer. For example, if we have 2 times 10 is to the power 2. This number in standard form. Why? You can see that the number here, 2, is between what? 1 and 10. And then 2 also is an integer. What is an integer? An integer is a positive or negative whole number. Including 0. At least all positive whole numbers, negative whole numbers, and it's 0. They are what? The integers. So you can see, you can also say 1.2 times 10 to the power minus 1 is in the standard form. Why? You can see 1.2 between 1 and 10, right? Also, minus 1 is an integer. What if I ask you, is 5 times 10 to the power 0 standard form? Yes. Why? 5, the number between 1 and 10, right? And then 0 is an integer. Remember I said earlier that integers are positive and negative whole numbers, including 0. That is, any number that is negative, any negative whole number, and positive both whole number, right? And 0. What if I have 0.5 times 10 to the power 2? In a standard form, no. Why? Because 0.5 is less than 1. Remember the first condition. The first condition is that a, the number between 1 and 10. That is, starting from 1 to numbers greater than 1, but then must be less than 10. Then say that 0.5 is less than 1. So starting from 1, so start from 1 volts up to less than 10, right? What if I have 1.8 times 10 to the power 0.5? Is it an in standard form? No. Why? Because you can see the power here is 0.5. He said n is the power here when b an integer, and 0.5 is not an integer, but 0.5 is 1 over 2, the fraction. He said an integer is a positive or negative whole number. 1 over 2 is a fraction, not a whole number. So I think we can identify numbers in their standard form. And then we have what we call the ordinary form. The numbers in ordinary form, normal numbers we know. Write 1000. Write 1000 in ordinary form. Write 0.0005 in ordinary form. Relax. They are all in their ordinary form. And we can convert from standard form to ordinary form. Converting from standard form to ordinary form. About that, there are two cases. It's one. The first case is when the power is greater than 1. That is n greater than 1. You can see what we said. I said 8 times 10 to the power n, right? That n it is greater than 1. That's the first case. How do we convert to binary form? Let's see examples. How do you do that? Then up 2 times 10 to the power 2. You can see the power here now. Power here is 2, right? It's greater than 1. So in other words, we can say 10 is positive. It's greater than v, rather. It's greater than v. But when we see a number is positive, it simply means it's greater than 0. Now, how do we convert this to a binary form? Now, simply add this 2. Now, write this number 3. Write it separately. Is 2.0. It means that any even number you have, 3, 4, 5, or anything. That's it. 0 after the decimal point. 10.0. 11 is 2.0. So this is also 2.0. Of course, the 0j is insignificant, then take it away. That's why we usually do not write. That is the way include it. But in this case now, we need it for a reason. So let's include it. 2.0. Now you can see the 10 is power 2 you have here. 10 is power 2 is telling us that we move this decimal point to the right twice. To the right twice. 1, 2. Can you see that? 1, 2. Then you can see we have 2 curves, right? We have 2 curves here. Now, for the first curve, we can see 0 is there. The second curve is empty. Anytime we are trying to convert to ordinary form, all the curves we encounter, what do we do? All the empty curves we encounter, we fill them with zeros. We see an empty curve, we fill it with 0. Just like this. We have 0, right? Empty. As for the first curve though, it's already filled with 0. The second curve, which is empty, we write 0 there, right? This piece we stopped at. We have to put the decimal point together. Remember, we really shifted this decimal point from where to there, like here. So the decimal point is no longer there, now here. And after it, now we put that 0. Then for every whole number, it always has a 0 at the end. But the 0 is insignificant. So it could be 0. This 0, this is 200.0. Remember, we said the 0 is no longer after 3. We shifted it from end there. That's why we have 200.0, which is equal to 200. Said the 0 at the end there is insignificant. I take it in. You can see how we've done this. This way to convert from standard form to ordinary form. What's another example on that? So if we have 4.5 times 10 to the power 4. In this case, what do we start with? Start with x in 4.5. And see 4.5 is already the decimal number, so we don't have to do anything. If it's an whole number, then we have to write it as probably 11.0, 3.0, 5.0. In this case now, it's already a decimal number. We write 4.5. Now, we know since n is greater than 0, n is positive, we are always moving decimal point to the right. What determines how many times I'm moving decimal point? Power of the 10. I think 10 has the power of 4 here, right? 10 is power 4. I'm moving it 4 times. And 1, 2, 3, 4. Here we stopped here. I think decimal points. Then you have a 0 at the end there. So all empty curves, we put them zeros, right? 0, 0, 0. Then you have 4, 5, 0, 0, 0, 0, and that's 45,000. Now still we remove decimal points to the end there, and then all those empty curves, we see them zeros. Let's take one more example on that. if we have 7.6 times 10 to the power 3, write our 7.6, right? And then we want to move the decimal point right to the right. Why? Because n is positive. N is greater than 0. How many times? That depends on the power of 10. 10 has the power of 3. That's 3 times. So you go 1, 2, 3. Let the stop, put decimal point there, and then 0. Those empty curves, give them 0, right? 0, 0. Then you have 7, 0, 0. Decimal points are removed again. 0. You have 7, 6, 0, 0. 7,600. And now we set the 0 after decimal point here is that give it out. So that way we can convert standard form back to ordinary form. That's for the first case when n is positive, greater than 0. For case 2, that's when n is negative. A negative number is simply a number is less than 0. When we say number is negative, which means the number is less than 0. So, example, here we have 2.7 times 10 to the power minus 4. You can see the power of 10 is negative. Minus 4. This if I'm moving decimal points to the left. You can see direction to the left. This is not equal to. And we write this also 2.7. Write 2.7, right? This decimal point is going to the left. How many times? Depending on the power of x. The power of 10 is other. Power of 10 is minus 4, right? That does not mean we're moving the decimal point minus 4 times. You can move the decimal point minus 4 times. 4 times. But there's negative sign of telling us that left. If it's plus 4, it's to the right. Minus 4 is to the left. Remember, right for positive, left for negative. If 4 is positive, to the right. 4 is negative, to the left. So 4 times to the left. As we know, minus 4. 4 times left. Plus 4 is 4 times to the right. So 1, 2, 3, 4. Also, when you stop here, there's my point set, then add 0. And those empty curves also, they fill them with 0, 0, 0, 0. And that is 2.00327. 0.00027. So we've been able to convert this to its ordinary form. Another example, let's say we have 4, for example, here, times 10 to the power minus 2. You can see we have 4 here. Anytime you have a whole number, what do we do? Try to include the 0 after the decimal point. We write it as 4.0, right? 4.0. If the number is decimal number already, we only have to decimal number do it is, and then you flip the decimal form. An whole number, try to write it as 0.0, right? So, then the power of 10 is what? Minus 2. Minus means we are going to be left, and 2 means we are going to left twice. 1, 2, let me stop decimal point, and then we have what? 0, right? We have just one empty curve here, which is 0, and that's 0.040. And that's it. Not that form. In its ordinary form rather. And then the third one here, we have 7.5 times 10 to the power minus 6. 7.5. Check the power. The power is minus 6. Minus means we are going to the left, and 6 means 6 times. So let's make decimal points. 1, 2, 3, 4, 5, 6. Then we come to the 0. Fill each empty curves with 0. 0, 0, 0, 0, 0. So we have 0.000. 0.075. In that, we'll be able to convert it to its ordinary form. And that's how we convert numbers from standard to the ordinary form. For the two cases, the case where n is positive, means the decimal point should be right. How many times? That depends on the power of 10. And for the case 2, when n is negative, you move decimal point left hand side. How many times? That depends on the power of the 10 also. Now, let's now reverse this operation in detail. That is, let's now convert from ordinary form back to standard form. Converting. We have to reverse what we did just now. Converting from ordinary form standard form. Now, although we use the same examples, so can be happy a bit. Result we had on the first question, we solve the words. Here also we have two cases. Case 1, the number is greater than 1. Case 1, number is greater than 1. That is, the number we want to convert back to standard form greater than 1. And the first one we have here is 400. Standard form 400. What do we do? Remember that for 200 is 200.0, right? 100.0. So all we do make, you now put the decimal point back to the left. Remember, we're only reversing what we did. We want to convert from standard form to ordinary form. For what? N greater than 0. What did it be? You get decimal point to the what? To the right. Here, we reverse our solution. Would take decimal points now back to the left. Back to the left, right? Now, go 1, 2. We'll move beyond 2. Okay. Because we said what to be in standard form, the number 8 has to be between 1 and 10. So if you move the decimal point beyond there now, we have what? 0.2, which is what? Which is less than 1. So and that in that way, something in standard form. We have to stop immediately before 2. That is, do not go beyond 2. Don't go beyond 2. Stop immediately before. So with that, we have 2.000. Remember, there's no point is now here. Now here. Because since it is now here, here we have 2.000. Then times 10 raised to power. 10 raised to power what? 10 raised to power 2. Why? Because we moved to the left 2 times. Because we moved the left 2 times. Why is it positive? Positive because the number we converted is what? Greater than 1. I think 200. 200 is greater than 1. That's why we have a positive power. Exactly. And then that's 2 times 10 raised to power 2. 2 times 10 raised to power 2. That is standard form. You can see it fulfills the 2 conditions. The 2 we have here is between 1 and 10, right? And then the 2 here is an integer. Second question would have it's 45,000. Standard form. What do we do? For the 45,000, we write it here to 45,000, 10.0, right? 0 the right hand side. 1, 2, 3, 4. Always stop before the number, before the last number you had there. Always stop before the last. You don't go beyond the last number you have there. You don't go and say 0.45. Okay? Making forward, making before 4. Stop them. So we have what? We have 4.5, right? The decimal point is now between 4 and 5. 4.5, 0, 0, 0, 0. 10 times 10 raised to the power what? How many times did we move? We move 1, 2, 3, 4. minus power 4. Why is it 4 and not minus 4? It's 4 because the original number converted is greater than 1. That's why the positive power. I remember we said all the zeros we have here are not significant. You can ignore them. So 4.5 times 10 to the power 4. Is that okay? The third example we have here is 7,600. That's 7600.0. Here also move decimal points to the left. We have 1, 2, 3. Remember, do not go beyond 7, right? 7 is the last number there, so do not go beyond it. So you stay between 6 and 7. That's 7.6000 times 10 to the power. How many times did you move? We moved 3 times 10 to the power 3. Why is it positive? Because the original number converted, which is what? 7600 is greater than 1. If it's greater than 1, power of 10 will be positive. That's plus 2. That's 7.6 times 10 to the power 3. You know, we said that these zeros say are not significant, so you can omit them. We have 7 points times 10 to the power 3. And this is how we convert from ordinary to standard form for the first case. That's when the number is greater than 1. The second case is when the number is less than 1. That's case 2. Number is less than 1. So also we try to use the examples, the results we got from the previous examples. The first one was 2.00037 convert to standard form. For this, we're also shifting the decimal point, but this time around it's to the right. Remember, when we're converting to ordinary form, just it leaves. This time around it is to the right. So we have 1, 2, 3, 4. This case also do not go beyond 7, right? We stay between 2 and 7. That's 2.7 times 10 to the power. It will be minus 4. Why? Because the original number is the number less than 1. You can see 0.00027, the number less than 1. So since it's the number less than 1, we have a negative power. Minus 1 will be the number. You can still remove decimal point 4 times, right? We have 4. And you can see this satisfies function of the standard form. 2.7 is the number between 1 and 10. And that's the reason for stopping between 2 and 7. Once you go beyond 7 now, what do you have? You go beyond 7, you have something like 27. Right? So you have to stay between 2 and 7. But that number will still remain the range of what? 1 and 10. Second one is 0.04. It's quite simple. If there's no point also to the right, we have 1, 2. This case do not stay between 0 and 4, because if you stay between 0 and 4 and then you just leave the original point between 0 and 4, it will not satisfy the condition of standard form, which says that what number A here has to be what? Has to be between 1 and 10. And you can see 0.4 is less than 1. That's why I have to take the decimal point out here, right? So that I would have 4.0. Once the decimal point is here, I can include 0 here, right? 4.0, which is now between 1 and 10. So the goal is just to make the number between 1 and 10 as a cheat there. Then times 10 to the power minus. Why is it minus? The original number 0.04 is less than 1. So what's the number that will be the power there? It's 2, because I moved the decimal point just twice. I have 4.0 times 10 to the power minus 2. In the third one is 0.0000045. Again the same way. In the decimal point to the right. 1, 2, 3, 4, 5, 6. I'm staying between 4.4 and 5. That's 4.5. If I stop at 0.4, you can see this number is now up to 1. That's around 1. And if I go beyond 4, I go to 5. Then what would I go? That have something like 45. It's also greater than 10. The number has to be between 1 and 10. That's why I stopped at 4 4.5. As I made the decimal point between 4 and 5. In that case, I would still be between 1 and 10. 4.5 times 10 to the power minus. Minus because the original number is 0.0000045. It's less than 1. So it is 10 to the power minus. And then what's the number there? How many times did I move? I moved 1, 2, 3, 4, 5, 6, 6 times. 10 to the power minus 6. I mean, that can convert from ordinary form back to standard form for the 2 cases. The first case, when the number you're converting is greater than 1, and the second case, when the number is less than 1. Thank you.